Welcome to another episode. Welcome to another episode of Sudoku and Variants, where I teach you how to solve Sudoku variants the easy way. The rules are simple. Place numbers 1 through 9 in each column, row, and 3 by 3 grid without repeating any numbers. Notice that two 9 by 9 grids overlap in the middle, creating a 2 by 2 grid that contains numbers shared by both 9 by 9 grids. This means that outside of these 2 by 2 grids, you will have numbers that are duplicates, but not all numbers will be duplicated. Plus, what numbers are in these left side columns will also be in these right side columns. Keep in mind though, this is only true for the left and right sides, top and bottom sides of these 2 by 2 grids. See the 4, 7, 6 in column 6 on the top row working downwards? These same three numbers will also be found at the bottom of this column where we see 6 empty square 4. Logic tells us that because of the shared grids, these 2 by 2 grids, we must have the same numbers up here and down here. This means that we can safely put in a 7 here. What I like to do is go around and fill in all the numbers that apply to this new logic that only applies to Sudoku variants to my knowledge. Look at the 5 and 6 in column 1. Column 1, row 4. Let's go to the right side in the same row and look at where we might put a 5 and a 6. Looking down column 8 and 9, I see 6's. Column 9 also contains a 5. I cannot not repeat numbers in this column. I know that column 9 will not take a 5 or a 6, and that column 8 cannot take a 6. Thus, I put the 6 in column 7 and the 5 in column 8. I will move on down to the next row and look at the 2. And we'll also look at the 9 in the same row. Now I do not see a 2 in column 7 or 8. Looking downward again and using cross hatching, I still cannot determine or tell where a 2 might go. Thus, I move on to the 9. Over in column 3, I do see a 9. I know I cannot duplicate the 9 in any column, so I know that a 9 cannot go there. Thus, I will put the 9 in column 2. The next row contains a 7 on the left side and an 8 and 7 on the right side. Because the 7 is already in on the right side, I will focus on the 8. Using cross hatching again, I do not see where the 8 can go, so I leave it for now. Row 7 on the left side contains the 3 and 7, as does the right side, so I skip it for now. Row 8 contains a 1 and 4 on the left side, but only a 6 on the right side. I know that I must put the 6 here, so I do. I then look on the right side to see if I can put in the 1 and 4. I know that I cannot put a 1 or 4 here. And I know that a 1 and a 4 cannot go down here. This means that in this column only these two squares can get a 1 or a 4. I then look at column 7 and see that a 1 or a 4 can go here or here. But they cannot go here. I also keep in mind that I have not ruled out these squares down here. I move on to the last row on the left side and see the 9. On the right side, I see a 9 and an 8. Focusing on the 8, I use my fave technique and see that there is no 8 in either column on the far left side. However, I need to look at all the other rows for 8s. I see in row 2 and 3 there are 8s. This means that these two squares cannot be 8s. That leaves only this square to be the 8. I move on to the top now. I will start with the 5 and 3. In column 4. I see at the bottom of that column we have a 2. This means we know we must put a 2 here. we look at row 8 and see a 3. Row 8, my foot. 3, 6, 9. Row 11. We look at row 11 and see a 3. This means we must put a 5 here. And then put a 3 here. Moving on to column 5, we see a 8 and 9. I look at the bottom of the row and at row 10, 11, and 12. Row 11 has the 8 and 9. So this means no 8 or 9 can go here. I see an 8 in row 12, so I put the 8 in row 10. And put the 9 in row 12. I also notice that I have one empty square. I fill it in. Just count 1 and you are done. However, we are not done. I can now put the 1 in the top of the column. And move to column 7 and see the 5 and 1. At the bottom, I see only a 5. I look at row 11 and see a 1, so I know that I must put the 1 in row 10 instead. Column 8. I see nothing, but on the very bottom, I do see a 7 and 9. I then look on top and do cross hatching and see a 9 here and 7 here. I will then consider what other numbers are missing in row 3. It's missing a 3, 4, and 7. Moving along to column 1, I find a 3. And a 4 in column 2. I do find a 7 in column 1. This means that the 4 must go in column 1. This also means that the 3 and 7 are toggled, as I call it. This means that a 3 or a 7 goes here or here. I am putting them in anyway. As pencil marks. I then look at the top row and see that a 3 or a 7 can go there also. I notice, though, that a 9 cannot go in column 2. The 9 also cannot go in column 3. I will now look at column 7 and on the bottom to see if I can put a 9 in this column. And at the top and bottom, I cannot. But we should have known this already because we know there is already a 9 here. This means that the 9 must go here. To recap, we cannot put a 9 in any other column because those columns already have a 9, or the bottom 3 by 3 grid already has a 9, and it is part of the 2 by 2 grid fun. If I stop mucking about, get the get the proper 9 in, yeah. No one needs a 9 out of 25 pixel pot. Mm. Moving on now. The you know uh, column 9 has an 8 8 on the top and the bottom, so I am moving on. Now for part 2 of our solving techniques. This is where we go row by row and see what numbers are missing, and see if we can figure out what goes there. Let's look at this top right grid here. I know that I am missing a 1, 2, 3, and a 4. I am going to focus on the 3 because I already focused on the other numbers earlier. Now I notice a 3 in column 11. I know the other square here takes a 1 or a 4. Thus, I know a 3 must go here. This also tells me where the 2 goes and where the 3 also goes. Remember, what we do to the left side must also be done to the right side. Because of the 2 by 2 grids that are overlapping. Sharing numbers in both larger 9 by 9 grids. This means that these 2 squares take a 1 or a 4. Looking at column 11, I am going to go to the bottom and see if I can find enough 1s and 4s in to determine which goes where. I will also look at what other number is missing. I am missing the 7. Now we have a 7 here, which means I cannot put a 7 in this square. Looking at the bottom row, I see a 7. I know the 7 must go here. And the 1 goes here, and 4 goes here, and 1 goes here. This is because there already is a 4 in this row. I am missing only one number, so I fill it in. I look at column 12 and row 8. I should be able to figure out where the 4 or 1 goes now. Because this last column has a 1, I know I must put a 4 here and the 1 over here. The last column is missing one number, so I fill it in. The 3 by 3 grid I can fill in as well. Simply fill in the only missing number. The bottom grid is missing a 4 and 9. I see a 9, so I put the 4 here and 9 here. Let's look at row 10 at the bottom. I am missing a 3 and 4. I see where a 4 is, so I put in the 4 here and 3 there. The bottom grid is missing a 2 and 6. And I do see a 6, so I can fill those numbers in. The logic being that we cannot duplicate numbers in the same column or row within the 9 by 9 grid. I am going to fill in the top row 1, column 7, as I now know that it takes the 2. I know the last column on top takes a 3 and 6. We can see where the 3 and 6 are in rows 1 and 2, so we can fill in those numbers now. The top row only needs a 7 and 8. I see a 7 in column 3, so put the 7 in column 2 and the 8 in column 3. Row 2 is missing a 1, 4, and 9. And I see the only place that can take a 9 because the other columns already have a 9. Because this 3 by 3 grid has a 4, so I know I cannot put a 4 here. I put the 4 here instead. I am also missing the 2. I do not see a 1 or a 2 in columns 2 and 3. I look at column 2 and see what numbers it is missing. 1, 2, 3, 5, 8. Notice something. We have a 7 right here. This means that our pencil marks can change to a 3 here and a 7 here. I am still missing a 1 and 2 in that upper box. Column 2 is still missing the 1, 2, 5, and 8. The bottom 3 by 3 grid has a 1 and 8. So I know that it must take the 2 and 5. As it has 2 empty squares. Looking across, I do not see a 2 or a 5. But I know that these other 2 squares must take a 1 or 8. I see an 8 here. So I put in the 1 here and 8 here. And then fill in the last number in row 2. Which just happens to be a 2. I look at the next 3 by 3 grid in rows 4 through 6. I am missing a 1 and 4. I see that row 4 must contain a 1, because of the 6-5-1 rule. or rather because of the rule that states what I do to the left side must also be done to the right side when a 2 by 2 overlapping grid exists. We fill in the 4 also and move on. Using that rule, we can fill in the 2 and 5. As some of you probably saw that earlier. I'm slow, folks. And now for something completely different. We are focused on the middle. Let's look at column 9 because it is only missing 3 numbers. It needs a 1, 5, and 9. I see where a 9 is here, and 1 is here. Telling me that a 1 must go here or here. And I know that this bottom square of the 2 by 2 grid is missing a 9. The 9 can't go in column 8, but can go in column 7. Now looking at row 7, I notice that the 9 can only go in one spot. I put it in. This leaves the 1 and 5 left. I do not see which goes where, so I move to the next column over. Let's move to row row 7 and 8 instead. And specifically this box. I am missing the 2, 3, and 5. I see a 2 and 3 here. Thus I can put a 5 there. I look for a 2 and find it in column 7, so I put a 3 here and the 2 there. This does not help me put in the 5 in the other column, so I am going to look at the next grid over to the left. The number 2 can only go in one spot. The 5 can go in two spots. The 6 can only go in one spot. The 7 can only go here. This leaves us with 8 and 9. I see where 8 and 9 are in this column 5. Meaning the 5 must go here. I see a 9 in this column 4, so I know that I must put the 8 here and 9 here. Moving up to that box with the 9, and I am missing the 1. And notice that 2 spots are valid for the 1. I look at the 2 and find it can only go in one spot legally. The 4 can only go here. This means the 1 must go here. You see where 1s already exist, leaving us only one legal spot. We are nearly done. The 5, 6, 7, and 8 are left. We have a 5 and 6 in the in row 4, so we must put them in row 5. We see a 5 and 6 in columns 5 and 6, so we can put in the 5 and 6 here. The 7 and 8. Column 6 has a 7, so I put an 8 here, and the 7 here. Looking at row 4, I am missing the 3 and 4. I look at column 7 and find a 3, so I can put in the 4 here and 3 here. The next row is missing 7, 8, and 1. I see the 1s in 2 columns, so put the 1 here. I see the 7s here. So put the 7 here and 8 there. The last 3 numbers are 5, 6, and 9. We can simply put them in by making sure of what other numbers are in those columns so as not to duplicate. And there we have it, folks. We solved our first Sudoku medium Sudoku puzzle variant. Congratulations! You did it! Please like, subscribe, and share. I hugely appreciate it. As you know, I do solve these. I do solve these as I type, and I try to go slower so that people can keep up. This is why my videos aren't as quick as other Sudoku solvers videos are. Thank you.